Given an arithmetic progression with the fifth term is 3 times the second term, show that sum of the first 8 terms is 4 times the sum of the first 4 terms. So we have to prove the sum of the first 8 terms is 4 times the sum of the first 4 terms. Step 1, we have to express the given condition in terms of A and D. Given that the fifth term is 3 times the second term in an arithmetic progression, the nth term of an arithmetic progression is given by Tn equals to A plus n minus 1 D. So the fifth term is equals to A plus 4D, and the second term is A plus D. So the condition is T5 is 3 times the T2. We have to apply A plus 4D equals to 3 bracket A plus D. So A plus 4D equals to 3A plus 3D. So D equals to 2A. Step 2, we have to express the sum of the first 8 terms in terms of A. The sum of the first n terms of an arithmetic progression is given by Sn equals to n over 2 bracket 2a plus n minus 1 d close the bracket. So sum of the first 8 terms equals to a over 2 bracket 2a plus 8 minus 1 d close the bracket. So sum of the 8 terms equals to 4 2a plus 7d. Substitute d equals to 2a into sum of the 8 terms. So S8 equals to 4 bracket 2a plus 7 2a bracket equals to 4 2a plus 14a. So equals to 4 16a equals to 64. Sum of the 8 terms is 64a. Step 3, we have to express the sum of the first 4 terms in terms of A. S4 equals to 4 over 2 bracket 2a plus 4 minus 1d bracket equals to 2 plus 2a plus 6a close the bracket equals to 8a. So equals to 16a. So we find out the sum of the 8 terms and sum of the 4 terms, the first 4 terms. Step 4, we have to show the required relationship. So we need to show that S8 is equals to 4 times the sum of the first 4 terms. From step 2, we get 64a. From step 3, we get sum of the 4 terms is equals to 68. Therefore, 4 times the sum of the 4 terms is equals to 4 bracket 16a is equals to 64a. Since S8 is equals to 64a and 4 times the sum of the 4 terms is 64a. So we have shown that S8 is equals to 4 times the sum of the 4 terms. So shown. So for the B question, an experiment was conducted to test the speed of a racing car over a distance of 1 kilometer. In the first second, the car traveled a distance of 10 meters. In each successive second, the car traveled 1.2 times the distance traveled in previous second until the whole journey is covered. Find the distance traveled in the 8th second and find the time in seconds needed to cover the whole journey. So in this situation, we know that this is an geometric progression. So step 1, we need to identify the first time and the common ratio. The first distance traveled is A is equals to 10 meter. The distance traveled in each successive second is 1.2 times the distance traveled in the previous second. So the common ratio is R is equals to 1.2. The total distance is 1 kilometer, which means we have to convert it to meter. So 1 kilometer is equals to 1000 meter. Step 2, we have to calculate the distance traveled in the 8th second. We need to use the formula for the nth term of a geometric progression is Tn is equals to AR n minus 1. So T8 is equals to 10 bracket 1.2 8 minus 1. So T8 is equals to 10 1.2 to the power of 7. So for the 8th second, the distance traveled is 35.83 meter for the 8th second. So in Roman 2, they ask find the time in seconds needed to cover the whole journey. So in this case, they ask to find the whole journey, which means we need to find the sum of the first n terms of a geometric progression. We need to find the smallest integer such that the sum of the first n terms is greater than or equal to 1000 meter. So we have to use the formula Sn is equals to A bracket Rn minus 1 over R minus 1. So Sn is equals to 10 bracket 1.2 n minus 1 over 1.2 minus 1. Sn is equals to 10 bracket 1.2 n minus 1 bracket over 0.2. Sn is equals to 50 bracket 1.2 n minus 1. In this case, we need 50 bracket 1.2 n minus 1 is greater than or equal to 1000 meter. So 1.2 n minus 1 is 1000 over 50. So in this one should be 20. So 1.2 n minus 1 is greater than or equal to 20. So 1.2 n is equals to 21. So we get like this. To solve the n, we need to use logarithms. So take logarithm of both sides, which means n log 1.2 greater than or equal to log 21. So n greater than or equal to log 21 over log 1.2. So log 21 divided by log 1.2, we get the answer 16.69. Since the time must be a whole number of seconds to cover the whole journey, we round up to the next integer. So the time in seconds needed to cover the whole journey is 17 seconds. That's all from me. Thank you.